Now I want to put all of this functional form discussion we've had together to discuss one tool that has become very popular in applied research in recent years, which is called regression discontinuity design. So it's really a nice example of applying all of this method of playing with functional form and dummies, etc., to understand something. So regression discontinuity design is appropriate in any circumstance, such as the Boston Latin example, where there is some treatment, for example, being admitted in Boston Latin, which shifts discontinuously with some running variable at a threshold. So call the variable A, but that's because I'm using someone else's notation. Usually we use X notation, but call this variable A for some reasons. And call your treatment dA equal A1 if A is greater than some threshold. For example, here I put the threshold as 21. Let's call the threshold alpha 0 and 0 otherwise. So we are going to use as an example, a very nicely done example in Josh Angrist's and Steve Pischke's book, Master of Metrics. They kind of dissect a nice article by Carpenter and Dobkin on blah, which I'm going to ask you in a minute. So it happens to be here that the threshold is 21, and dA is equal to 1 if you are above the threshold and 0 otherwise. What do you think the treatment is in that example? Something of interest that shifts discontinuously at 21. Yeah. Drinking age, exactly. So this is something that is relevant to many of you. So you pay close attention, even if you're not interested in econometrics. dA is 1 above 21 and 0 otherwise. So the idea is that we're going to look at an outcome. What do you think, what would be an interesting outcome to look at that is related to drinking age?
Hospitalizations.
Yeah, or even one step further. Yeah, so they look at fatalities actually. They look at motor vehicle fatalities. And the idea is that as you become, so that's related to my example with mobility over IQ. So the well, that's not. It's, I guess because it's IQ that goes down once you've drunk. So the idea is that as people become older, they probably become more reasonable and better drivers. So motor vehicle accidents should, in general, probably go down with age. Except that at 21, something discrete happens, which is you get the right to drink. So you might be starting to drink and drive at 21, which was not possible before. So the idea is in regression discontinuity design is that you assume that your outcome of interest does vary with something that is going to influence whether or not you're treated or not. So the potential outcome is related to whether you're treated or not, because the same thing that affects the potential outcome also affects the treatment. But there is a discontinuous jump, and the assumption that we are willing to make is that there is no other reason for the discontinuous jump other than the fact that the treatment has changed. So there is no other reason why you would become a worse driver at 21, other than you might have drunk before. You might have been able to buy alcohol before. So it's important to know that this is always an assumption that there is no shift at 21 in the outcome variable, and that the assumption is not usually directly testable. You have to appeal to your knowledge of the institution to know that it is likely to be a valid assumption. Sometimes you can provide some little auxiliary regressions to give you confidence in the assumption, but that's always an assumption. So what can you do in this setting? Well, the simplest thing you can do is to use a dummy variable for treatment to shift the intercept at A0. So what you assume is that we're running the regression that we saw with dummy variable. We assume that the slope of the relationship between your outcome on the left and on the right of the discontinuity is the same. But then there is a treatment. It suddenly shifts up or down depending on whether you can drink. So given what you were discussing before I show up the graph, how do you think that motor vehicle fatalities will look like as a function of age? If I'm taking the predicted value from this regression, what will the, putting 21 here, how should it look like? Yes, exactly. So it's decreasing till here. Then maybe it's going to shift up because of the ability to drink, and it's going to be decreasing again. So this is a regression that you rarely see in practice, because quickly enough people go and do more richer stuff. So the very nice thing about Josh's book is that he's going step by step, and this is the graph that he ran for us. So the dots are for each age, what is the average death rate from all cause, actually. And the lines is the predicted value from this regression, and with the jump, with the intercept shift over here. So that's the simple thing you can do. So here these lines are parallel because you've assumed that they were parallel. Okay? The estimated lines are parallel. In fact, it's not a bad. It doesn't seem to be a very bad approximation of the graph, but it's assumed in this case. Yes.
Similar to the China pollution example.
Very similar to the China example. Exactly. This is exactly the same idea. What I was just describing about Boston Latin, very similar. So it's very, very popular. People use it at boundaries. Oops.